Hi everybody, let's look at 1.6 number 3. We have a Norman window, which is a window in the shape of a rectangle topped by a semicircle. A particular Norman window has a perimeter of 200 inches, and we want to find a function a of x representing the area of the window in terms of the length of its base x. So let's take a closer look at this. We have our semicircle right here and the rectangle here. So in this problem, we're interested in the perimeter and the area. We're given information about the perimeter, which we're going to use to help us write the area of the function in terms of its base. And so let's start with the perimeter. The perimeter means we want to add up all the sides. We don't care about this part here. We're just interested in the top part of the circle, and then these two heights, and then this length. I'm going to go ahead and call this y, and then there's two of them. And we know that the circumference of a circle is, using the diameter, is pi times x. We could just as well use the radius, but I'm going to stick with the diameter. And just remember it's divided by 2 because it's half the semicircle. It's half of a circle. And so we know the perimeter is 200 equals pi x divided by 2, and then plus x plus 2y. 2y because when we add up those sides. Alright, we can simplify this just a little bit by writing this as 200 equals pi over 2 plus 1 times x plus 2y. And let's pause here for a second and let's look and see what we have with the area. Again, I'll start with the circle first. So the area of a circle is pi r squared, and in this case I want to use the radius. So the radius will be x over 2, and I also just have half the circle, so my area will be, for the semicircle, 1/2, or let's even say pi over 2 times x over 2 squared. So that's half the area of a circle with a radius of x over 2, and then plus the area of a rectangle, which is going to be x times y. This will simplify to pi x squared over 4 times 2, so all divided by 8, plus xy. And when we go back and look at the problem, it wants us to represent the area as a function of its base x. And so we want this y to be in terms of x so that the area will be in terms of x. And to do that, we should solve for y. Alright, so when we solve for y, I'm going to start by subtracting this term to both sides. So I'll have 200 minus pi over 2 plus 1 times x equaling 2y. I'll then divide everything by 2 or multiply it by a half, and so that'll leave me with 100 minus, and I'll go ahead and distribute the 1/2 through this part, so I'll have minus pi over 4 plus 1/2 x equaling y. And Now I'm going to plug that expression for y here. That's a long line, so let's just get that out of the way. We want to plug this part in here. Let's use that space. So now what we're saying is we're going to have a function for the area in terms of x. So this will equal pi x squared over 8 plus x times 100 minus pi over 4 plus 1/2 x. And let's go ahead and clean this up. And so we'll end up with kind of going down this way, pi x squared over 8 plus 100 x minus pi over 4 plus 1/2 times x squared. Okay, we can combine, we'll be able to combine these, well, let's use a different color. We can combine the x squared terms and then we'll be done. So I'm going to go ahead and factor out the x squared on these two terms and then play with the constants. So I'm going to have pi over 8 minus pi over 4 minus 1/2 all times x squared plus 100x. I need the least common multiple for the denominators, so I can multiply this on the top and bottom by 2, and then on the top and bottom for 1/2 by 4. And so this is going to lead me to, we're going to get pi minus 2 pi, which is going to be negative pi over 8 minus 4 over 8, so minus 1/2. I didn't need to do the 4 there. So, well, we can all keep it over 8, so we can say, we'll say negative pi minus 4 over, just put that negative with the pi. Negative pi minus 4 over 8 x squared plus 100x. And this is our answer for the area in terms of x. All right, I hope you found this helpful, and keep up the great work, everybody.